Welcome to our data analysis course. Today we're diving into exploratory data analysis, or EDA for short. Before you start building any models or making predictions, it's crucial to explore your data. EDA is the process that helps you truly understand your dataset, its patterns, trends, and any unusual points that might exist. Think of EDA as the detective work before the big case. By taking the time to explore, you'll set yourself up for success in all your data projects. Let's see why EDA is so important and how you can master it. Why is EDA considered the most important step in data analysis? Simply put, it helps you avoid costly mistakes. By exploring your data first, you can spot missing values, outliers, and patterns that might otherwise go unnoticed. This process ensures you don't jump to conclusions or build models on faulty assumptions. In real-world projects, skipping EDA can lead to inaccurate results and wasted time. That's why every data analyst, from beginner to expert, relies on EDA as their foundation. First step in EDA is understanding the structure of your data. This means looking at how your data is organized, how many rows and columns it has, what each column represents, and the types of values you're dealing with. By getting a sense of the overall shape, you can plan your analysis more effectively. This step is like reading the table of contents before diving into a book. It sets the stage for everything that follows. Missing values can cause big problems if left unchecked. During EDA, you'll want to scan your dataset for any gaps or blanks. These missing values might be due to errors in data collection or simply unavailable information. By identifying them early, you can decide how to handle them, whether that means filling them in, removing them, or using special techniques. This step helps ensure your analysis is accurate and reliable. Outliers are data points that don't fit the general pattern of your dataset. They can be caused by errors, rare events, or just natural variation. During EDA, spotting outliers is key because they can skew your results or indicate something important. By visualizing your data and running summary statistics, you can quickly identify these unusual points and decide how to handle them. One of the most exciting parts of EDA is discovering patterns in your data. Patterns can reveal trends, relationships, or even hidden insights that you might not expect. By using visualizations like charts and graphs, you can see how different variables interact and spot trends over time. This step is where data starts to tell its story, guiding your next steps in analysis. Let's get practical. The first technical step in EDA is checking the shape of your dataset. In Python, you can use the shape attribute to quickly see how many rows and columns you have. This gives you a snapshot of your data's size and helps you plan your analysis. Knowing your dataset's shape is like knowing the size of the puzzle you're about to solve. Next, you'll want to look at the first few rows of your dataset. In Python, the head function lets you preview the top entries. This quick look helps you spot any obvious issues like unexpected values or formatting problems. It's a simple but powerful way to get familiar with your data before diving deeper. Understanding the data types in your dataset is crucial. Are your columns numbers, text, or dates? In Python, you can use the dtypes attribute to check this. Knowing your data types helps you choose the right analysis techniques and avoid errors down the line. It's a small step that makes a big difference. Summary statistics give you a quick overview of your data. By using the describe function in Python, you can see key metrics like mean, median, min, max, and standard deviation. These numbers help you understand the distribution of your data and spot any irregularities. It's a fast way to get a sense of what's normal and what's not. Correlation analysis helps you see how different variables in your dataset relate to each other. Are some columns strongly linked? Do changes in one variable affect another? By calculating correlations, you can uncover hidden relationships that might be important for your analysis or modeling. This step is essential for building accurate models later on. See EDA in action with Python. Start by importing Pandas, a powerful data analysis library. Load your data using pd-read CSV, then use head to preview the first rows and describe for summary statistics. These simple commands give you a wealth of information about your dataset in just a few lines of code. It's a great way to get started quickly and efficiently. One of the biggest benefits of EDA is that it helps you avoid drawing the wrong conclusions from your data. By thoroughly exploring your dataset, you can catch errors, inconsistencies, or misleading trends before they affect your results. This careful approach ensures your analysis is based on solid ground, not assumptions. EDA isn't just about cleaning data, it also improves the accuracy of your models. By understanding your data's quirks and characteristics, you can choose the right modeling techniques and avoid common pitfalls. This leads to better predictions and more reliable results, which is the ultimate goal of any data analysis project. In real-world projects, EDA is absolutely essential. Whether you're working with business data, scientific research, or any other field, taking the time to explore your data pays off. It helps you avoid costly mistakes, make better decisions, and deliver results that truly matter. That's why EDA is a must-have skill for every data analyst. Another important step in EDA is checking for duplicate entries. Duplicates can distort your analysis and lead to incorrect conclusions. In Python, you can use the duplicated function to find and remove these extra rows. Keeping your data clean ensures your results are accurate and trustworthy. Many datasets include categorical data columns with labels or categories instead of numbers. Handling these correctly is key to good analysis. You might need to encode categories as numbers or group similar categories together. Understanding how to work with categorical data helps you get more accurate insights from your analysis. Visualizing the distribution of your data is a powerful way to understand it. Histograms, box plots, and density plots can show you how your data is spread out, where most values fall, and if there are any unusual patterns. Visualization makes complex data easier to interpret and helps you spot issues quickly. Scatter plots are great for visualizing relationships between two variables. By plotting one variable against another, you can see if there's a trend, cluster, or outlier. This visual approach helps you quickly understand how your data points interact and whether there are any interesting patterns worth exploring further. Box plots are especially useful for spotting outliers and understanding the spread of your data. They show the median, quartiles, and any points that fall outside the typical range. By using box plots, you can quickly identify values that might need special attention in your analysis. Histograms are a classic tool for visualizing the distribution of a single variable. By grouping data into bins, you can see where most values fall and whether your data is skewed or symmetrical. Histograms make it easy to spot patterns and decide if you need to transform your data before analysis. Pair plots allow you to visualize relationships between multiple variables at once. By plotting every variable against every other, you can quickly see which pairs are related and which are not. This comprehensive view helps you decide where to focus your analysis and which variables might be important for modeling. Heat maps are a great way to visualize correlation matrices. By using color to represent the strength of relationships between variables, heat maps make it easy to spot which variables are closely linked. This visual tool is especially helpful when working with large datasets with many variables. Once you've identified missing values, you need a plan to handle them. Common strategies include filling in missing values with the mean or median, using interpolation, or simply removing rows with too many gaps. The right approach depends on your data and analysis goals. Handling missing data carefully ensures your results are as accurate as possible. After spotting outliers, you need to decide what to do with them. Sometimes, outliers are errors that should be removed. Other times, they represent important events or rare cases. Carefully consider the context before making changes. Document your decisions so your analysis remains transparent and reproducible. To use categorical data in models, you often need to convert categories into numbers. Techniques like one-hot encoding or label encoding can help. This step ensures your models can process all the information in your dataset, leading to better predictions and insights. Feature engineering is the process of creating new variables from your existing data. By combining, transforming, or extracting features, you can make your data more useful for analysis and modeling. Good feature engineering can dramatically improve your results and reveal new insights. Scaling and normalization are techniques used to adjust the range of your data. This is especially important when variables have very different scales. By bringing everything to a similar range, you help your models perform better and avoid bias toward larger values. Sometimes, transforming your data can make patterns more visible or improve model performance. Common transformations include taking the log, square root, or applying other mathematical functions. The goal is to make your data easier to work with and more suitable for analysis. Data cleaning is a crucial part of EDA. It involves removing errors, fixing inconsistencies, and making sure your dataset is as accurate as possible. Clean data leads to better analysis and more trustworthy results, so never skip this step. As you work through EDA, it's important to document your steps and decisions. This makes your analysis reproducible and helps others understand your process. Good documentation is a hallmark of professional data analysis and sets you apart from the crowd. Python offers a variety of tools for EDA. Besides pandas, libraries like Matplotlib and Seaborn are great for visualization. These tools make it easy to create charts, graphs, and plots that bring your data to life. Learning to use these libraries will make your EDA faster and more effective. For larger projects, automating parts of your EDA can save time. Tools like Pandas Profiling or SweetViz can generate detailed reports with just a few lines of code. Automation lets you focus on deeper analysis while still getting a thorough overview of your data. Even experienced analysts can make mistakes during EDA. Common pitfalls include ignoring missing values, overlooking outliers, or failing to document changes. Being aware of these mistakes helps you avoid them and ensures your analysis is as robust as possible. To get the most from EDA, follow best practices. Always check your data's structure, visualize distributions, handle missing values carefully, and document your process. These habits will help you produce high-quality analysis every time. In business settings, EDA is used to uncover trends, understand customer behavior, and make data-driven decisions. By exploring data thoroughly, companies can identify opportunities, reduce risks, and improve performance. EDA is a valuable skill for anyone working with business data. Scientists use EDA to explore experimental data, identify patterns, and test hypotheses. By carefully examining their data, researchers can draw more accurate conclusions and design better experiments. EDA is a cornerstone of scientific analysis. If you're new to EDA, start simple. Focus on understanding your data's structure, visualizing distributions, and checking for missing values. As you gain experience, you can add more advanced techniques. The key is to be thorough and curious at every step. As you become more comfortable with EDA, you can explore advanced techniques like dimensionality reduction, clustering, or time series analysis. These methods help you uncover deeper insights and handle more complex datasets. Continuous learning is key to mastering EDA. Once you've completed your EDA, it's important to share your findings clearly. Use charts, summaries, and well-written reports to communicate your insights. Good communication ensures your analysis has real impact and helps others make informed decisions. EDA is a skill that improves with practice. Stay curious, keep learning new techniques, and apply them to different datasets. The more you explore, the better you'll become at uncovering valuable insights and solving real-world problems. Let's review some key concepts in EDA: understanding data structure, detecting missing values, spotting outliers, discovering patterns, and using visualizations. Mastering these basics will set you up for success in any data analysis project. To sum up, EDA involves checking your dataset's shape, viewing the first rows, understanding data types, running summary statistics, and analyzing correlations. Each step builds on the last, giving you a complete picture of your data and preparing you for deeper analysis or modeling. EDA is more than just a step in the analysis process, it's the foundation of good data science. By exploring your data thoroughly, you set yourself up for accurate, meaningful results. Whether you're a beginner or an expert, EDA is a skill worth mastering. Now that you understand the basics of EDA, it's time to put your knowledge into practice. Start exploring your own datasets, try out the techniques we've covered, and keep learning every day. With EDA as your foundation, you'll be ready to tackle any data analysis challenge that comes your way.